When I was a freshman in college, I had the opportunity to build a packaging machine. That led to the opportunity to develop it into an entire packaging system. This is the story of how I built that system.
Good morning. It is about 3:55 this morning, and I wanted to do a quick update to share kind of what I'm working on. So here we've got the frame for the cartoning machine. And over here, this one's the frame for the traying machine, and I've got a little space set up back here. I've got the de-stacking assembly that I'm working on, and so that one will pull trays off of a stack. And then down here, you can see I've got some other parts that I've welded up on a huge shelf of stuff that's waiting to go on the machine. So I realized I should probably start videoing my journey and showing the problems that I run into along the way. Good morning. After about 2 weeks in Africa, I'm back at it. So it's about 3:30 on a Sunday morning. Check this out. We got machined parts. We got parts from Keans, parts from McMaster-Carr. Out back, I've got some powder-coated frames, which means it's time to get to work. It's now all on me to just make it happen, which is a wonderful feeling. So good engineers think about how stuff is made, and great engineers think about how stuff is assembled. I was thinking I could assemble this entire thing and just slide it into the table, but I neglected that there are a whole bunch of bolts here that do not fit, but there's absolutely no clearance in the width, and then there's a couple other things that don't fit. So this is one of those things I should have thought of beforehand. All right, so about 45 minutes later, it only took a lot of finagling, but it is installed. So yesterday when I got back from Africa, the frames didn't have anything on them. A bunch of sub-assemblies that had not been assembled. There really wasn't much, at least it didn't look like much. And here we are a day and a half later. This is why I love this part in the project. There's one piece that's missing. This little tiny piece right in here that's clamped on there, I just forgot to weld. I could take this entire thing off, but it would take several days to disassemble and reassemble everything. Instead, I've packed it with cardboard, and that will keep the spatter from defacing the machine.
Ah, yes, my cardboard packing has been successful. There's two little itty bitty baby welds I will grind off because they're ugly, but it's welded.
Check this out. Just got the boatswain on. So, and this boatswain is cool. The thing that I really like, the big difference between that machine over there and this machine is this. It's all of these little mechanical position indicators. All the critical adjustments it has. You can control the height. You can control the lateral position. And then this one is cool
because with this one, we can control the timing. The cup actually rotates. It's times like this where it becomes very evident that I don't know what I'm doing and I probably should have hired a professional. In lieu of doing that, we're gonna figure it out. I'm starting to wire the machine, and I think I had unrealistic expectations going into machine design. When I was first starting on the Knockout 250, I thought to myself, you know, I need something for controls. I'll probably use an Arduino. And that was my introduction to industrial controls. And then I realized that didn't work, and I worked up to a PLC, and then I realized you need more things for your PLCs, and all of a sudden I have this huge control panel and it's way too small. But I'm gonna change it from this janky setup where we have DIN rail, and then wire cover, to DIN rail up top, wire cover, another DIN rail, and then another wire cover. I think that'll be more professional than this mess. I have to say, I'm actually really pretty happy with how it's coming together. But I think it's also important to show where you started. I don't often show this, but I think it's important to show that this is where I started. And I'm embarrassed to even show it, but I think it's important to show how far I've come. All right, for the very first time, I'm about to plug it in and see if it works. We're about to figure out if I wired 8 drivers, PLC, the power supply, and all of it correctly. I really hope this doesn't blow anything up. I think that's a good sign. Well, I think it's important to show your failures just as well as your successes. And now it doesn't error. The current setting, the gain for the current was turned all the way down. So I turned it all the way up and it's significantly stronger. The good news is I figured out why the steppers were not acting like closed loop steppers. They work just perfectly fine. I had 2 of the encoder wires backwards. The bad news is, I think in the process of figuring all this out, I burned up a motor and a driver separately. I got this thing rewired with the encoder wires correct, and it seemed fine, but then it burnt out a second motor. And so now I have 2 motors that don't work, and I have absolutely no idea why. Nothing indicates that it should have killed them, but it is dead as a doorknob. So I'm not sure what to do about it. I have to figure out why it's not working, and I also have to figure out why it's not talking to the PLC. But we will get there, one way or another. So this is kind of a big deal. I got the hopper in. Today with Nate, we spent maybe 45 minutes, and with the forklift, we were able to hoist this guy in there and get it mounted. Look at the difference. It's like a whole different machine. So I'm starting to get the pneumatics working slowly, and there's a couple issues. One of them is that they're so frickin' violent. And that's at like a quarter of the pressure the machine's probably gonna operate at. The good news is I don't have any needle valves on them currently. And so once I put some needle valves on there to regulate the flow into the cylinders, they'll hopefully get significantly less violent. So it's good to see that stuff is starting to work, and kind of terrifying to see how much I have to dial it back. Okay, whoever designed this thing was a freaking idiot. That's a port to one of the air cylinders, and it needs a needle valve. And it's also the most difficult place to reach on the entire machine. I'm not sure who put that there, or why they would think that was a good idea. After quite a bit of effort, and possibly some foul language, the needle valve is in. Well, something cool happened today. The collator arrived. That's one of the last big pieces to be assembled. Left to do, obviously, are the upper doors, and those are getting welded next door. And then the control panels. I need to do the electrical cabinet for the traying machine. Not for this machine. It's in pretty good shape. I'll show you some of the issues that I've been running into. One of them is the mouse traps. It was getting bound up. They're too wide. The springs on them, they also were causing them to jam. And that's an easy one because I can just trim the springs shorter, and then I think that'll work. There's some work to do on those before they're actually working. It's gonna take quite a bit to get those perfect, I think. Okay, despite the fact that there are so many problems with what I'm about to show you, I'm excited because I just got something cool done. All the pneumatics are in and they're all doing something. Check this out. The first issue is a bit of a leak. Okay, maybe a little more than a bit, but check this out. The clamps are actuating backwards. This one is not quite working. This one should be lifting it, but I think because of the leak, it's not getting enough pressure. Look at that, it's moving. Can you see back there? Can you see that it's moving? I'm not sure if you can. There's stuff moving back there. And those are the clamps on the other side. That's what grabs onto the tray. And then so, yes, I realize that pretty much nothing I just showed you worked. But when I fix some leaks and when I adjust some valves and when I redo a couple connections, it's going to be beautiful. I now control the real world with my computer. Check this out. So I'll try to explain kind of how this works. So right in there, initially it'll be like this. And then the upper clamps will close, then the lower clamps will close, and then they'll be pulled apart. And then the lower clamps will open. There we go, lower clamps open. And then the tray is pushed on in. Then, on the other side, this will initially be in this position. The tray will come down towards it. It'll clamp onto the tray. It moves the tray out. The clamps open, and then they move down the conveyor. For whatever reason, one of them's not right. It'll push it on off. Stuff is actually moving. Please join me as we test this for the very first time. I'm super nervous because now I'm about to actually figure out whether it works or not. It'll start like this. The upper clamps come on, and the lower clamps. And here we go. Oh my goodness, it just worked. And then the lower clamps come on, and they're pushed in. Yes! Look at that! And these come back, and then we'll try that again. Whole thing comes up. Drop the whole thing, lower clips off, and push it in. Oh, that's beautiful. The whole machine, for the most part, is all connected, and I figured out what that leak was. I had 6mm push to connect fittings, and it's all 1/4-inch hose, and those are not quite close enough to actually work. They're close enough to look like they would, but they're not the same. So now I'm doing the electrical cabinet for the tray filling machine, and these steppers still are not working. The infeed conveyor is. But every other stepper that's this brand, I cannot get the drivers to talk with the PLC. So I spent like 45 minutes on the phone with someone from Keyence today. We couldn't figure it out, so I'll have another call tomorrow. It's nice having help on that stuff. I'm not in this completely alone. But that's the one thing that I wish I could really change right now, is I wish I could have all these things just working. So these suckers were not feeding quite right. And Nate had the good idea to put some wedges in here. The issue is that it's not quite aligned. So you can see how much space there is on that side and how much space there isn't on that side. But now, thanks to the wedges, it's about the same. Nate's the frickin' MVP today because these wedges are working. Check this out. You see that? It worked.
there it goes again. Look at it go. Well, check this out. Something is actually working. So I got the IV3 hooked up, and so there's first a position correction tool, and that's that bar you can see in the front. And what that does is it locks onto the tray, and then with, you know, at least 3 pictures, you can train the whole thing. Right now, it thinks it's great, but if it's missing one, that's not great. Here's the other cool thing: if one is upside down, that's also not great. You can see just by the lights on the IV3 that it doesn't like that. It likes that though. I need to use the camera as a trigger for the rejection shoot. The issue is that if it has nothing, it calls that a bad part. And really, I just want to signal when there is a bad part. If there's no part or a good part, then do nothing. So I gotta figure out how to do that. Oh shoot. Dang it. There we go. So today made a bunch of progress. I took the programs that Randy's been working on, kept working on them, started implementing them into the HMI. This is kind of cool. When it pulls the tray out, if the tray is too close, oh, never mind, that's not working. There's lots of work to do, but this is awesome because this is the point where it starts looking like, hold on, I'm gonna clean this up. Okay, after screwing with only a few settings, I think it's actually working. As soon as the tray is moved down the conveyor, shuttle comes in to grab the next ones, and obviously nothing is timed right now. Shuttle comes out, drops them off, goes back and grabs the new ones. But what will happen is as the shuttle comes out, this will be about there, then the shuttle waits, and eventually the whole machine is waiting on the shuttle. Then the shuttle can go ham, grabs the next one, and then it'll pull it out. Lots of timing stuff still to work on, but the structure is there. It's just a matter of getting the settings in. These are the very first 2 trays that made it from that side of the machine to this side of the machine without me touching them. Here we go. Look at that. Take a look at this. First we're going to home the machine. Now the machine is homed. think it's important to not just show where you end up, but to show where you start. We're at 111 parts per minute, and we need to get this needle down here in this range at 240 parts per minute. We got a ways to go, but we're gonna get there. I got the boatswain up and running, but the chain would go from tight to loose. I think it's because this guy's off center. That one's aligned, that one's pretty well aligned, and you can see there's no clearance on the bottom, lots of clearance on the top. And if you flip it around, it does the exact same thing, which means it has nothing to do with the sprocket. It's because the shaft is off. So it's not perfect, but it's significantly better. The other thing I did that helped this out is I cut some bigger flats in the actual shaft of the stepper. Who says you can't take an angle grinder to nice pieces of equipment? So sometimes really easy things take way too much time. Today I programmed the code for homing all the axes, and most of them was done in about 5 minutes. And then the chains here, of course, they're a little bit strange because the deal with them is that I'm homing 2 axes with 1 sensor. So of course it's going to be a little bit tricky. We have to move both of them forward until we find a point where it's safe to home them, and then home them one at a time, which sounds really simple when I explain it to you like that, but then when you sit down and try and write code, here we are, one full Sunday later. So here's one issue I'm having right now. The ammo going up the conveyor is falling out. Okay, I'm not gonna deny that there's still lots and lots of problems and moving at a snail's pace, but it's working. Look at that, and they don't fall out. At least most of the time they don't. So here's the story. Today I got a couple iterations done on this thing, and it's kind of working, but I'm realizing it's never gonna be very reliable. So I got thinking about other solutions and how I could make it simpler. So this is what I'm testing out next. It has slots in it such that when it turns to rotate around the corner, it's hopefully not gonna jam. They're gonna be about like that so that the ammo can slide over both of them, but then they can hopefully rotate with each other. We'll see how it works. So the spring-loaded doors idea didn't work. The whole zigzag stopper idea didn't really work. And the first rendition of these doesn't really work, but it does show a lot of potential. I think this idea, it has the ability to work. Rev 6 is in the garbage and we're on to Rev 7. It's printing now and it'll be ready in the morning. We'll try it again. Alrighty, here's the situation. Hernan is coming at 8:30 tomorrow morning to check on the progress and just see the machines for the very first time. Before that happens, I'm going to get that conveyor working. I want to get the trays all the way from the tray magazines onto this conveyor going that way before they get here. And today I just got the parts in to do it. So we're gonna put everything together, gonna do some programming, gonna do some taking apart and adjusting and fixing all the stuff that isn't right, and hopefully we can get that done. Let's do it. All of this is a bunch of useless crap that took me like 4 hours that doesn't work. And then this right here, this little tiny section actually works. The first one comes in and hits the prox sensor. The second one comes in and hits the prox sensor, and bada bing bada boom, they're home. Well, shoot. That's not what was supposed to happen. See, I can get them to see. I'm working on that and it's getting pretty darn close. Here's the issue. I moved the chain backwards because it was hitting this thing, and that was a mistake. So now I have to move it forwards, and then I'm gonna grind off whatever I need to here so it has enough clearance. That side's working, this side isn't. And then we'll be here in 6 hours. Good morning. It's about 4 in the morning, and strangely enough, I'm actually going to bed and not waking up. The machine's pretty much ready. The team from Hernon is showing up here in only a few hours, so I'm gonna go take a nice little nap, take a shower, and I'll be back here in just a couple. All right, check it out. Here's what we got this morning. I got the new boatswain in, just got machines. Programming is pretty much squared away for testing at least. So now we're actually gonna fire it up, just got the compressor on. I'm gonna start doing the first real test runs of this machine. In theory, everything is here and has the ability to work. In practice, we're about to find out that's not true. But it's only one way to know. Let's do it. Nice. Boom. That's a start. Today I hit probably the biggest milestone yet. It's the very first lot. We're running at about 200 parts per minute, so I need to speed it up a bit, but it actually went a lot smoother than I thought it was going to, which is a very pleasant surprise, because with that machine, everything that could go wrong went wrong, and everything else that I couldn't even imagine going wrong also went wrong. With this machine, there's some issues, but a lot of things went right. A lot of things just worked the first day. That machine never had a day where it ran as smoothly as these did. You know, we were running for 10-15 minutes a couple times without stopping. And eventually I want to get it so this thing, you know, doesn't stop at once an hour maybe. See a couple of things that really helped this machine. The first one is that little suction cup. It grabs the box and then it opens it a little bit with that, and that helps a bunch. The second thing are these little ramps. These guys right there. What they do is that even if the carton is sticking up a little bit, they kind of push it back down. And between those two things, this part is actually really reliable. So I'll share with you one of the biggest problems I had with this new cartoning machine. I went with a ball screw right here to push the trays in, and I think that was a mistake. The issue is that stepper motors lose torque significantly with speed. They have the static torque. They've got crazy static torque. And right now, the machine is limited to about 10 boxes per minute. So I've designed a tray pusher with a rack and pinion.
Alrighty, it is officially time to move that machine way back over there and hook it up with the other one so we can start testing. Alright, so for the first time I'm going to try running a whole lot through both of these machines. So I just finished up the last bit of the very first lot that I ran through both of these machines. I know this should be a huge milestone, but man, it doesn't feel like it. Probably got my hopes up with the cartoning machine because that machine actually does run pretty well. But that machine there is so full of problems. So many things are wrong. I'm having alignment issues, having homing issues,
Bunch of useless crap.
I'm having all kinds of issues. And that is frustrating. So, there's still a lot to do. Check it out. It's been running. As you can see, the belt is now white. To increase contrast between that and the tray, it can lock onto the position of that tray faster.
So much better. Gets caught on nothing. Boom! Sees another problem. Boom! Get rejected. So the problem is, when the laser reaches into these holes, it hits the bottom of the holes and it doesn't actually detect the tray. Here's what I'm doing to fix it. I have my sensor for the trigger, and I'm gonna mount it right here. Didn't really like it there, so instead I put it right here. Right here lies one of the biggest problems. Ammo keeps bouncing when it goes through the chutes. It'll go into the tray and bounce out. Here's how I'm gonna fix it. I started off with straight chutes. I tried something like this. This actually helps, but it doesn't do it well enough. They're still going too fast. So next, I'm gonna test this. Check it out, the shipments are coming in. These are all the machined parts that I've been waiting a few weeks for now. These are my attempts to fix my screw-ups, and get that traying machine running. I've been optimizing the crap out of it, and it is actually legitimately running at 304 parts per minute. Alright, now the name of the game is building out all the changeover kits. I got this thing running decently reliably, and it's getting better every week, but I only got a month before I am out of here and back to school. We got it running 9mm pretty well. Next is going to be the large pistol stuff. If we can do those two, we can run pretty much everything in pistol. I would love to get at least one rifle caliber in there. Got myself a tent, small pistol, large pistol, 20 count, 50 count. And so, gotta figure out how to weld in the rain. Just fired up the machine and started running the very first 50 counts ever, because we got all of these FMJs to run. And as you may have guessed, it all went perfectly without a hitch. Oh wait, no it didn't. The conveyor here actually is working really well. These new carriages that I got are pretty slick. I also have these modified downshoots, and with these new chutes, so far I'm pretty happy with them, but there's a couple of issues. So I'm printing some more, but overall, this is actually dialed in fairly well. At first, I couldn't get it to place the cartons in the chain. I was hoping that because these 20 counts should be the same as the 50 counts, just longer, that I should just change out the boatswain and then it would be fine. But unfortunately that wasn't quite the case. I had to change quite a few adjustments, but it seems to be working pretty well now. This is a huge milestone. Today it successfully ran some 20 count rifle. The cartoning machine is running 20 count rifle, which is good because this is the only type of packaging that is incredibly challenging. The things that I didn't think were going to work or that I was really nervous about, I was able to fix. The biggest one being the flipping. And so now that that's working, I can sleep a little better at night. And I know that this project is going to come to fruition. This is what